In example 5, it says finding the scale factor in ratios of similar solids. Identify the scale factor, the ratio for each pair of similar solids. So in this case, we know they are similar, but we have to find the scale factor, the surface area ratio, and the volume ratio. Up here, it tells us that the ratio of corresponding areas is a squared and b squared, and the ratio of the volumes is a cubed over b cubed. So the bottom line is you got to find the scale factor before you can do any of this. So I'm going to pick two sides to compare, or two measurements to compare. I like this 6 over 3 right here. So I'm going to go 6 over 3 and reduce that to 2 over 1. So that's my scale factor. For surface area, I just square that. So 2 squared and 1 squared makes 4, 1. For the volume, I go back to the scale factor and I cube it. So 2 to the third power is 8, and 1 to the third power is 1. Okay, so part B, same thing. So we pick one of the measurements to compare. So I'm going to go 4/6. I'm going to do radius to radius. So 4/6, and that reduces to 2/3. So that's my scale factor. Then I square that for the area, and I get 4 over 9. And then I take that and I cube it, so 2/3, but I cube it, so that would be 8 and 27. And then example 6, it says, identify the scale factor for each pair of similar solids. When given surface area or volume, always find the scale factor first, A to B. And then it says that we need to find the rest of this. So, first of all, we were given surface area. So we have to decide, like, how do we figure out the scale factor from this given surface area? So I'm going to go 25 to 4. If that's my area, the opposite of squaring it would be square rooting it, and that would be 5 over 2. So 5 over 2 is my scale factor. This is already my surface area, 25 over 4. But once I have the scale factor, I just cube these two numbers to get my ratio. So 5 to the third and second to the third gives me 125 to 8. Okay, in part B, we have volumes. Okay, so let's go ahead and set up our ratio. And for this one, if we're given the volume and we have to go backwards to scale factor, you have to do something called the cube root. So it looks like a square root, but there's actually a little 3 right here. On your calculator, if you click Math and go down to number 4, it has the cubed root and then it has a parenthesis. So you go to 4, you click Enter, and then you put your number in, 729. That's 9. So then I want to do the same thing. I want to go Math, 4, and then put the 1331 in. Gives me 11. So that means that the cubed root of our two numbers here for volume gives me a 911. This is my scale factor. Now, because I was given volume, that go ahead and goes right here for volume ratio. And then how do I get surface area? Well, I take the scale factor and I square it. So 9 squared, 81, and 11 squared is 121. Okay, for letter C, for this one we're given the volume as well. So 162 and 384. All right, so let's try the cubed root here. So math 4, put in 162. Okay, well, it gives you a decimal. So if it gives you a decimal, then you want to go ahead and try to reduce that fraction to see if you can get a perfect cube root. So let's see, we know that 2 goes into both of those numbers. So if we divide by 2, we get 81 and 192. Okay, well, let's see, 192 is divisible by 2, but 81 is not. Alright, so for these two, let's just try dividing those by 3 so we can get cubed roots. So 81 divided by 3 is 27. And 192 divided by 3 is 64. Now let's cube root 27, and that came out to be 3. And cube root 64, and that comes out to be 4. So my scale factor is 3/4. And I use this one because it's like the lowest cubes I can go is 27 over 64. But to get the surface area, square 3 squared and 4 squared. So 9 and 16. Okay, last one. Here we're given surface area. So we have 960 over 375. Alright, so immediately I know neither of these are perfect squares. And if you don't know that, you could put in 960 and see that it comes out a decimal. So it's not a perfect square. So I need to reduce this, okay? So let's reduce by 5, since 0 and 5 are my endings here. So 960 divided by 5 is 192. 375 divided by 5 is 75. Okay, let's try 3, because we need to, so still, these are not perfect squares. So 192 divided by 3 is 64, and 75 divided by 3 is 25. Now we have perfect squares. So we currently know that our surface area is this right here, 64 over 25. To get the scale factor, I square root those, and that gives me 8/5. Then once I have the scale factor, I can cube that, 8 cubed and 5 cubed, and get the ratio for volume, which is 512 to 125.